Hello students, let's today discuss our next chapter of chemistry, class 10, metals and non-metals. In metals and non-metals, actually elements are categorized into three: metal, non-metal, and metalloid. Metals, non-metals, and metalloids. Today we will discuss metals and non-metals. What is metal? The elements which form cations by losing electron, they are called as metal. For example, sodium. When sodium loses an electron, it becomes sodium Na plus. So sodium is a metal. We will take an example, chlorine, that it gains an electron and it becomes Cl minus. So positives are metal, negative are non-metal. We will not discuss about metalloids today because it's not in our chapter. For example, gallium is a metalloid which shows metallic properties as well as non-metallic properties. Some properties of metal, some properties of non-metal. Now we will discuss physical properties of metal. Physical properties of metal. And non-metal. First we will discuss metal. Metals are generally solid. Only one metal, which is mercury, is exception. Metals are generally solid, all metals solid except mercury. All metals are hard. Metals are generally hard. Some exceptions are there like lithium, potassium, sodium. They are very soft metals. They can even cut with a knife. Next, metals are luster. Lustrous property is there. Luster means what? If you will see any metal, it is shining. Its shining property is known as lustrous. All metals are shining. Next one is malleable. Malleable means it can be drawn into a thin sheet. Like you can see any metals, if you will beat, it can be spread and it can be made like a sheet. So that property is called as malleable. Next one is metals are ductile. Ductility property means it can be drawn into wires. For example, copper. Copper is having copper is ductile property. All metals are ductile property. Means if we will beat any metal, then it can be drawn into wires. That is ductility. Metals are having high melting point and boiling point. Metals are having high melting point and boiling point. Some metals, some exception are there. Gallium and cesium, they are having very low melting point and boiling point. If we will take gallium or cesium on our palm, then they can be melt very easily. So they are having low melting point and boiling point. And metals are having are good conductor of heat and electricity. Good conductor of heat and electricity. Good conductor of heat and electricity. Best conductor is silver. Silver is best conductor. After that, copper. That's why copper wires are used in making electrical wires. But there are exceptions like lead and mercury are poor conductor of electricity or bad conductor of electricity. Metals are sonorous. Sonorous means if we will hit any metal, it is not a metal, so you can't see, you can't find any noise, ringing noise. But if you will find, if you will go to a temple, there are bells are there. Bells are made up of metal. So when you ring that bell, it will just produce a sound. That sound is called as sonorous property. Sonorous. For non-metal, here metal, and now we will discuss physical properties of non-metal, just opposite of a metal. Generally, non-metals are solid or gases, but one non-metal is liquid, that is bromine. So like this, non-metals are solid or gases, but one exception is there, that is bromine. Bromine is liquid, solid or gases, but bromine is exception. Bromine is liquid form, in liquid form. Bromine is in liquid form. Non-metals are soft. All non-metals are soft, but there is also an exception, that is diamond. Diamond is the hardest substance found in the nature. Diamond is an allotrope of carbon. It is a form of carbon, allotrope of carbon, so it is the hardest substance. It is an exception. Non-metals are non-lustrous, non-sonorous. Non-lustrous non-metals are solid and they are having low melting point and low boiling point. Bad conductor of heat and bad conductor of electricity also. They are bad conductor of electricity. But one exception is there, graphite. Graphite is a good conductor of electricity. That is also a allotrope of carbon. Non-metals are non-sonorous, means if we will beat non-metal, then they will not produce a ringing sound. Now we will discuss chemical properties. I hope that physical property is clear. Now chemical properties. First we will discuss chemical properties of metal. Chemical properties of metal. In chemical properties of metal, first we will discuss reaction with oxygen. Reaction with oxygen. When metal reacts with oxygen, they form metallic oxide. For example, copper, we will take 2Cu plus oxygen, 2Cu plus O2, we will get 2CuO, copper oxide, cupric oxide. Some when metals form oxide, some metals are acidic in nature. Oxide form of a metal can be acidic in nature, and some oxides are basic in nature. For example, 2Na plus O2, 2Na plus O2, we will get 2Na2O, 2Na2O. Here again, when this Na2O will be treated with water, Na2O plus water, we will get NaOH, 2NaOH, sodium hydroxide. It is basic in nature. So base, this is a base, so it is basic. This metallic oxide is basic and this one is acidic. Sometimes what happens, they show both the property of basic as well as acidic. So at the time we can say that is basic property as well as acidic property. In aluminum oxide, they are called as amphoteric oxides. Aluminum oxides are called amphoteric oxide. That might come in your exam. What is amphoteric? Amphoteric oxide. When any oxide shows basic as well as acidic property, they are called as amphoteric aluminum oxide Al2O3 plus HCl, we will get 6HCl, we will get 2AlCl3, 2AlCl3 plus 3H2O. Here HCl plus Al2O3, we will get 2AlCl3 plus 3H2O. Then this one Al2O3, when it will be reacting with sodium hydroxide, Al2O3 plus sodium hydroxide. At that time we will get NaAlO3, NaAlO3 plus water. Here it shows it reacts with acid, means it is showing basic in nature. Here it is reacting with base, so it is acidic in nature. Same aluminum, here it is basic, it shows basic property, here it is showing acidic property. Is it clear? While it is reacting with acid, it shows basic property. While it is reacting with base, it's showing acidic property. I think it is clear. Next one is reactivity of different metals with oxygen. Reactivity means how metals react with oxygen. All the metals do not react with oxygen at the same rate. Like high reactivity series and moderate middle reactivity series or less reactivity series is there. So we have to go for the reactivity series. Like potassium, sodium, they are very highly reactive reactive metal. Potassium, sodium, they are highly reactive. So if we will keep sodium or potassium outside, when it touches with oxygen, it reacts with oxygen in open air, then automatically it catches fire. So sodium and potassium, they are kept in kerosene or any petroleum product. They are kept in kerosene or any petroleum product, that they cannot catch fire easily. Otherwise they can catch fire easily. They react with oxygen very easily in open air, atmosphere. When magnesium is burnt in air, it will give us a very bright flame, white flame. When iron is heated, it is very it reacts very slowly, it glows brightly also, it will give you a bright flame. When copper is heated, it doesn't burn, but it turns into black coating. And silver and gold, they do not react with oxygen, so they are very reactive, very less reactive. Where sodium and potassium are high reactive, gold and silver, they are least reactive. So we will go to the next one, reaction with water. I think it is clear. Now reaction with water. How metal react with water? When metal react with water, it produces hydrogen gas. For example, 2Na plus H2O, 2Na sodium plus 2H2O, we will get sodium hydroxide plus 2NaOH plus H2O gas will release. We can take another example, calcium plus H2O, calcium plus H2O, we will get calcium hydroxide, CaOH whole twice, plus H2 gas will release. Here we can see sodium reacts with water, it produces hydrogen gas. When calcium reacts with water, it also produces hydrogen gas. So metal reacts with water to form metal oxide. It is metal oxide, okay, and metal hydroxide also. This is metal example of metal hydroxide and hydrogen gas. Another example I will give, 3Fe plus H2O. 3Fe iron plus H2O. It will give us a, it is hydroxide. Now it will give us a oxide. Fe2O3, Fe2O3 plus hydrogen gas will liberate. In all the cases, whether it is basic in nature or acidic in nature, it will produce hydrogen gas. So it is clear that it will give us metallic oxide or metallic hydroxide along with hydrogen gas. Next one is same as oxygen, as oxygen in high reactivity series to low reactivity series, like I said that potassium, sodium are very highly reactive, okay, and silver and gold is very less reactive. Least reactive is gold, silver also. So when we will go from top to bottom, the reaction will increase. When we will come from downward, then the reactivity will decrease. For example, already we discussed the sodium and potassium reacts vigorously with oxygen as well as water. Same thing happens here. Sodium and potassium catches fire very easily on water. They reacts very easily on water, and gold and silver, they do not react. Next one is reaction with acid. I hope reaction with water is clear to you. Now reaction with acid, dilute acid, or we can say dilute acid. When metal reacts with dilute acid, it forms salt and hydrogen gas. For example, magnesium plus 2HCl, Mg, magnesium plus 2HCl. We will get MgCl2 plus H2 gas will liberate. Magnesium chloride and hydrogen gas. Magnesium chloride is salt, we will get a salt plus hydrogen gas. And the example we can take Zn plus 2HCl, zinc plus 2HCl, we will get ZnCl2 plus H2 gas will liberate. Is it clear? When metal reacts with acid, it forms a, we will find a salt and hydrogen gas will liberate. Clear? It varies from metal to metal that how according to reactivity series. So you have to remember that reactivity series, that which is the higher order in reactivity series and which is the lower order in reactivity series. 2 times I told that sodium, potassium is the highest one, very high, then sodium, and last one is least one is silver and gold. They do not react. Sometimes hydrogen gas is evolved, but when it reacts with HNO3, hydrogen gas will not evolve. For example, 3Cu plus, sorry, erase. In case of HNO3, nitric acid, 3Cu plus 8HNO3. Here hydrogen gas will not liberate. Here we will get 3Cu NO3 whole twice plus 4H2O and plus to NO2. Here no hydrogen gas liberates. Why? Because HNO3 is a reducing agent itself, so it will not it produce any hydrogen gas. Now reaction of metal with the metal salt solution. Reaction of metal with the reaction of metal with the salt solution. With the salt solution. Here also reactivity series comes, like more reactive metal can displace less reactive metal from its salt solution. For example, magnesium, we will take magnesium with the copper sulfate. Magnesium plus copper sulfate. Magnesium can displace copper from its salt solution. Here we will get MgSO4 plus Cu will be displaced. Why? Because magnesium is more reactive than that of copper. Copper cannot displace magnesium from its salt solution, but magnesium can displace copper from its salt solution. So it is also a displacement reaction. Is it clear now? I think it is clear. I hope it is clear. Now how do metal and non-metal reacts? Next one is, how do metals and non-metals react? Already I told you metals are positively charged particles, and non-metals are negative. So when, suppose I will take an example, cation and one anion, sodium. Let us take sodium. What is the valency of sodium? 1. What is the valency of chlorine? 1. One metal and one non-metal I will take. One metal is sodium, chlorine is non-metal is chlorine. Sodium's, we will do the electronic configuration of sodium. It is 2, 8, 1. So 1 is the valence electron. Here 2, 8, 7. Here also 1 is the 7 is the valence electron. So what happens here? This sodium can give this electron to chlorine. So sodium can give away 1 electron and chlorine will take 1 electron, gain 1 electron, it will lose 1 electron, it will gain 1 electron. So when sodium will give 1 electron or lose 1 electron, you can say lose 1 electron, so it will become sodium plus 1 plus ion will be there, plus 1 minus electron, 1 electron minus. Here what happens? Chlorine gains 1 electron. Is it clear? When it gains 1 electron means it is gaining on 1 negative charge. When it is losing 1 electron means it is gaining a positive charge. This one. It is gaining 1 electron, it is losing 1 electron. So it will become, now it become 2, 8. Its electronic configuration 2, 8. It is now stable. It is also stable 2, 8, 8. Clear? So when they mix with each other, sodium and chlorine, they become sodium chloride. It becomes, when they mix with each other, then sodium chloride, Na plus Cl minus. It is sodium chloride salt we will get. Is it clear now? It's an ionic bond, because transfer of ion is there, so it is called ionic bond. Clear now? Next one is formation of magnesium chloride. Also same thing occurs, MgCl2. Next one is occurrence of metal. This is very important. This will come definitely. This will occurrence of metal and purification of metal definitely will come in your exam. This is also very important. This will come in your exam. Might One more question. Occurrence of metal. Where metals can be occur? How we can get metals from their ore? Metals, some metals like gold and silver, platinum, we are getting them freely, free state. Free state means we are getting it directly from mines. So first one is mineral, second one is ore, third one is purification, third one is gong. Mineral, which we find from the mine, that is called mineral. What we are getting from mine, that is mineral. But sometime if percentage of the metal is more, then it is profitable for us. So that is called ore. When profit is more, we can extract the metal for profit manner, then it is called ore. And the waste particles present there is called gong. The impurities, waste particles or impurities present in ore is called gong. What is the impurities? Like salt, clay, any sediments, they are impurities. Now we will go for extraction of ore. This is very important. Extraction of ore, that will definitely come in your exam, board exam. Make sure that this will come in your exam. Make sure. In extraction of ore, in extraction of ore, first we have to enrich the ore, that is called concentration of ore. Concentration, that is called enrichment also. Enrichment of ore. Second one is called reduction. Third one is refining. Reduction. Third one is refining. When we will refine, after that we will get the pure metal. To get pure metal, we have to go with this process. First we have to concentrate. In concentrate means what? We have to remove the impurities. First we have to wash it. We have to clean the impurities, gongs, by different methods. So I will make the table here. Ore, okay, ore having, we can categorize three types. First one is metals with high reactivity. Metals with high reactive. Second one is metal with the moderate, medium reactivity or moderate, or medium, we can say medium reactivity. Third one is less reactive. Different processes we have to follow. For here we have to go for electrolysis. Then we will get the pure metal. When we will go for electrolysis, we will get pure metal. But here the ores are different types of ores. We will get carbonate ore or sulfide ore. In middle reactive, two types of ore we will get: carbonate ore and sulfide ore. In sulfide ore and carbonate ore, for carbonate we have to go for calcination process. Calcination. Here we will go for roasting process. Here calcination process, here roasting process. After that, we will get the oxide form of metal. We will get oxide of metal. Then oxide will have to be reduced from the metal, so it is called reduction. Then we will get pure metal. Here in less reactivity series, sulfide ores are available. Sulfide ores means it is roasting. From that roasting, directly we will get metal and we will refine it. Again, quick recap, ores are three types: metals with high reactive, metals with moderate reactivity or middle reactivity series, less reactivity series. First we will go for the high reactivity. In high reactivity, nothing has to be done. Only electrolysis is the only process. From here we will get directly pure metal. But here in moderate or middle reactivity series, there are two types of ores available: carbonate ore and sulfide ore. For carbonate ore, we will have to go for calcination, and for sulfide ore, we have to go for roasting process. Well, after these two processes, both the processes, we will get oxide of metal. Oxide of the metal has to be removed. Then when oxygen will be removed, that is called reduction. Then we will get pure metal. Here in less reactivity series, we will get only sulfide ore. For sulfide ore, as we know that roasting process is the process, so we have to go for roasting. Then we will get metal and pure metal. Pure metal will be refined, and then we will get some impurities will be there left over there. Those impurities will be purified. Then we will get in the process of refining. Then we will get pure metal. Shall I erase then? We have to remember this. Next one is that extraction of metal from first low reactivity series or high reactivity series. In high reactivity series, already I said, in high reactivity series what? Only the process of electrolysis. What is the electrolysis process? In electrolysis process, what we have to do is that we have to take, we have to set up a we have to set up like this: one anode and one cathode, and one anode, positive and negative, and some salt solution will be there. Suppose we will extract copper from its solution, from copper from the copper metal. Then we have to take here some solution. Okay. Then anode and cathode. In anode, positive is there. Anode means what? Impure metal will be fixed in anode. Anode, impure metal. Remember this: impure metal will be at anode, and in pure metals will be at cathode. Pure metal. A copper strip, a pure copper strip will be taken here, and impure copper will be here. Impure copper means what? Copper along with some gum. Then what will happen when we will electrolysis it? When we will charge, we will flow electricity. What will happen? The copper will dissolve and it will deposit here, and the impurities will be deposit here. This is called as the impurities of gum, and pure metal will be deposited here. By this process, we can get copper or any metal by electrolysis process. Those are highly reactive. Then we will go for that less reactivity series. Then we will discuss moderate, low reactivity series or less reactivity series. Low reactivity series like mercury, already we know that it is very less reactive. Metals or low reactivity series can be reduced by metal by heating in the presence of oxygen. When we heat in presence of oxygen, then that is called roasting. In presence of oxygen means it is roasting. Without absent of oxygen is called calcination. So we have to go for that roasting process. Mercury is obtained from its ore called cinnabar. Cinnabar is HGS. HGS is the mercury ore, cinnabar. When we will heat in presence of oxygen, HGS, 2 HGS will be heated in presence of oxygen. We will get 2 HGO in presence of oxygen. Heat will be provided. Then we will get HGO. HGO plus 2O2. HGO, mercuric oxide. When mercuric oxide again heated, in the excess heating will be provided to HGO will be again heated. Then we will get Hg plus we will get O2 oxygen. 2Hg plus oxygen. We will get pure mercury here. Low reactivity series. Clear? Low reactivity series is clear. Now we will go for thermit reaction. What is thermit reaction? When excess amount of heat will be released, that is called as thermit reaction. Thermit. Thermal means what? Thermal means temperature. Thermit reaction means thermit reaction. What is thermit reaction? When excess amount of heat will be released, that is called thermit reaction. When metal oxides reacts with oxygen, sorry, when sometimes some metals like sodium, calcium, aluminum, etc. are used for reducing agents, they form metallic oxides. When the reaction between metallic oxide and aluminum is highly exothermic, metallic oxide along with aluminum, that is highly exothermic reaction, means a huge amount of heat will be released, that is called thermit reaction. For example, Fe2O3 plus aluminum 2Al, we will get Al to O3 plus 2Fe plus huge amount of heat will be released. This heat, due to this heat, and it is a huge amount of heat, in this thermit reaction is applicable when rail tracks are joined. Two rail tracks are joined, this reaction occurs. Huge amount of heat is required. This process is going on. That is called thermit reaction. Clear? Next one is calcination and roasting. Already I told you, I think, what is calcination and what is roasting. Metals with middle reactivity series, they are calcination, and roasting process will be going on. Calcination means what? Calcination means calcination is in the presence of oxygen, and roasting means absence of oxygen. That is the difference between that. First we will discuss roasting, then calcination. Roasting is the heating of an ore in the presence of oxygen. For example, 2ZnS plus oxygen in presence of oxygen, 3O2, heat will be provided. Then we will get 2ZnO, zinc oxide plus 2SO2, sulfur dioxide will be released. Okay, so we are getting here ZnO, zinc oxide. When ZnO again treated with ZnO will be heated with carbon, then we will get zinc metal, pure metal plus carbon monoxide. We will get carbon monoxide. Clear? This is the roasting. This is roasting. While we will go for calcination, there is absence of oxygen, that is called calcination. Clear? Roasting and calcination. Next one is our corrosion. Corrodes means sometimes corrosion. Sometimes what happens, metals gets rusted, like iron gets rusted, brown coating is there. Sometimes in copper brown coating is there, sometime in silver black coating is there. That is called corrosion due to reaction with oxygen, sometimes carbon dioxide. Their damage means the color fades. That is called corrosion. So how we can prevent corrosion on the metals? Can be prevent from corrosion by applying some grease. We can apply grease by painting the metals, by galvanization, by tinning. By tinning means by coating coating of another metal, by electroplating, by electroplating, by alloying. Alloying means what? By making it alloy. What is alloy? Alloy is a mixture of two metals, that is called alloy. Metals or sometimes non-metal also. For example, steel is an alloy, brass is an alloy. Brass is a mixture of copper and zinc. Brass normally copper and zinc. Okay. When in an alloy mercury is present, that is called amalgam. Amalgam means when in an alloy mercury is present, that is called amalgam. So that's all for today. I hope today's video will be helpful to you. So we will meet again in next class. Thank you. Have a nice day.